Okay, so day 2 is inverses. A relation is a function if it passes the vertical line test. A relation has an inverse if it passes the horizontal line test. The graph of an inverse is a reflection over the line y equals x, which is why when we find an inverse, we swap x and y, because that's what a reflection over the line y equals x does. This will be very important. The domain of f of x is equivalent to the range of the inverse. The domain of the inverse is equivalent to the range of the original. One-to-one function is a function. A function is one-to-one if every output corresponds to exactly one input. So every y corresponds to exactly one x. In order for a function to be one-to-one, it must pass the horizontal line test. So they say, is the following relation a function? If it is the function one-to-one? Explain. Okay. So to determine if it's a function, basically my x's can't be repeated in going to two different y's. So the way we're going to say that is, yes, it is a function because every input, or x, corresponds to exactly one output, or y value. Now, is it one-to-one? Okay, well then the y's can't repeat, which they do. 6 is a y value twice. It corresponds with an x value of 2 and with an x value of -3. So we're going to say no, not one-to-one, because there is an output, and I could specifically say 6, that corresponds to more than one input, and that'd be 2 and -3. Okay, it says confirm that f and g are inverses by showing f of g of x equals x and g of f of x equals x. So a lot of times they'll say show, confirm, prove. So you have to do f of g of x. So put the g of x into the f of x wherever you see an x. Now, you do have to show, so you have to show that you know first order of operations, you would do these two, and those are 0, so you'd have 4x over 4. Then the 4's cancel, and you have x. You don't do that all in one step. You have to show that you know order of operations. G of f of x, that's putting the f of x into the g of x anywhere we see an x. So that'd be 4 times x plus 3 over 4, and then -3. So again, I show that I know order of operations says to multiply those first, then 3 minus 3 is 0, so we get x. So we confirmed those are inverses. Here, f of g of x, put the g of x into the f of x anywhere that you see an x, this whole thing. So it's -5x minus 3 over 2x minus 1 minus 3 over 2 times -5x minus 3 over 2x minus 1, and then plus 5. So to simplify, we've looked at multiplying by the least common denominator. Okay, on the top we got negative 5x minus 3. We're going to distribute a negative 3. Here we're going to distribute the 2. Here we're going to distribute the 5. Okay, so on top we have negative 11x. On the bottom we have a negative 11. So that's x. That gives us x. G of f of x. We put the f of x into the g of x. Okay, so I get negative 5x minus 3 over 2x plus 5 minus 3. And then I got 2x minus 3 over 2x plus 5 minus 1. So then I have to multiply everything by 2x plus 5. The least common denominator. So there's those cancel. I distribute the negative 5. Here I distribute the negative 3. So that's negative 6x minus 15. Here I distribute the 2, 2x minus 6. Here I distribute the negative 1. So negative 2x minus 5. So I get a negative 11x on the top, a negative 11 on the bottom, so that's x. Okay, find a formula for f to the negative 1 of x, give the domain and range of f and f to the negative 1, including any restrictions inherited from f. Okay, so swap x and y, solve for y. So I have to know this is y equals, right? So I swap x and y, and now I'm going to solve for y. And then we need to replace the y. So I guess maybe I should have a step 3 here. Replace y with f to the negative 1 of x. So I should say f to the negative 1 of x is x plus 5 over 4. Okay, so let's see. The original 4x minus 5, that's a polynomial. Its domain is all reals, which means that's the range of the inverse. The domain of the inverse, this is equivalent to 1/4 x plus 5/4. That is also just a polynomial, so that's all reals, making this all reals. Now, this one, we're going to have to be a little careful when we do our domains and ranges. So, y equals square root of x minus 5. Swap x and y. Solve for y. So now I have to square both sides. F to the negative 1 of x equals x squared plus 5. Now, the reason this one's tricky is we actually have to think about, well, first of all, the domain. X minus 5 is greater than or equal to 0. X is greater than or equal to 5. So I'm going to say 5 to infinity, which is the same thing then for the range of the inverse, 5 to infinity. Now, the tricky part is if I just looked at the domain of the inverse, looks like it's all reals. What I really have to look at first is what's the range of the original. So if we think about it, this is a square root function that's been shifted right 5. So if I think about that, 1, 2, 3, 4, 5, I have a square root function shifted right 5. So we said that an inverse is a reflection over the line y equals x. So if I reflect this thing, what's going to happen is it's going to look like this. It's just really going to be half of this parabola, not the whole thing. That's because a parabola does not have an inverse because it does not pass the horizontal line test. So we can't look at the entire parabola. We're restricting it. So since the range of the original function, so remember this is the f function, this is the f to the negative 1. The range of the f function is 0 to infinity. So that is the domain of the original. So you have to actually think of how the range of a square root function is 0 to infinity before you do the domain of the inverse. Okay. Next one, and this is actually the last one. So we're going to swap x and y. So I'm just going to go right to doing that. Then I'm going to cross multiply x times y plus 3. I'm going to distribute. So a lot of times people get to this step and then they don't know what to do. So I'm going to put a step 1 here. This is after we've done everything we know how to do. Get every term with a y to one side and every term without a y to the other side. So I'm going to move my y's on the left side, and I'm going to move everything else that doesn't have a y on the right side. This way I can do step 2, which is factor out a y, factor out a y, and solve for y. So I'm factoring out a y, and then I'm going to solve for y. So f to the negative 1 of x equals negative 3x minus 2 over x minus 3. Okay, so for domain of f of x, if I look at f of x, numerator tells me all reals, denominator tells me x cannot be negative 3. So all reals except negative 3, which is then the range of the inverse. The range or the domain of the inverse. So the domain of this thing is all reals except for 3. The range of the original then is all reals except for 3. All right, that is it for day 2.